backlight. Okay, engine stop.
We copy you down, Eagle.
Houston, Tranquility Base here. The Eagle has landed. Okay, Houston.
30 years ago, in July 1969, Apollo 11 landed on the moon. And first Neil Armstrong, then Buzz Aldrin, stepped out onto the bleak rocks of the Sea of Tranquility.
That's one small step for man, one giant leap for mankind.
Good evening. I remember that very well. I was in television Studio 7 doing a commentary as they actually stepped out onto the moon. And that was a great moment. And you know, pictures from Apollo are still being released. Here's one from Apollo 16, taken 1,000 miles in 1972. And here, another from Apollo 11, showing part of the lunar surface about the size of Switzerland. And remember, here's Al Bean showing a container of lunar soil. And by the way, if you want to see these pictures, they're on show at the Hayward Gallery, South Bank. Well, today, 30 years later, the moon's on the news again for a totally different reason. This time, the moon's going to act as a screen, blot out the sun, and give us the first English total solar eclipse since 1927. And believe me, it'll be a great sight. And to join me, well, we'd like to welcome Brian May. Now, Brian's famous musician is so great, one tends to forget he's also a highly qualified research astronomer. Welcome to the Sky at Night, Brian.
Thank you very much, Patrick. It's a great privilege to be here.
It's a lifelong hobby, isn't it?
Absolutely, a lifelong passion, which I think you're to blame, because I remember seeing the sky at night from about 10 years old when I was a kid, and I was completely enraptured by your stories of the stars, and I rushed out and bought all your books, and the music too, as a matter of fact. And I guess I pursued music and astronomy more or less equally. I more or less still do in a way. I still have a passion, although I'm an amateur astronomer these days.
And of course your main research was in zodiacal dust.
It was. I did a thesis on dust in the solar system, and you have an excellent picture of this, I know, which is roughly what the zodiacal dust looks like after sunset. It's very hard to see, isn't it, in fact?
Well, I took that one to La Palma. You don't very often see it well here, but it's a nice sight.
Yes, you need to be in the tropics, really. I was in Tenerife, not too far away, doing my observations. So if you were in space, you'd see that at total eclipse time, wouldn't you?
Well, dust lit up by the sun, but now this time the moon's going to act as a screen and blot the sun out. And you've been to quite a few eclipses, haven't you?
I have indeed, yes. I've attempted 5 and seen 4, I would say. The one that escaped being Mongolia. We drove into a snowstorm and saw very little, actually, but it was still spectacular in its own way.
I've been 7 or 8. I missed one in Finland. What was your first?
First time, I went really on an impulse to Baja California in Mexico, and in 1991 saw a really fantastic eclipse, and I think I was hooked from that point. I actually attempted some pictures at the same time, and I think I had beginner's luck because I got a couple of quite reasonable pictures.
That's a beauty.
The diamond ring effect there, and you can see a little prominence there, very beautiful, and of course the solar corona, which was probably something similar to what we might expect in August.
Just about able to think. You know, we've been talking about eclipses now for some time, and there are still some people who are not quite sure when or why or how an eclipse happens.
Yes, well, we have a little picture by way of explanation. Here's the Earth going around the sun, making its journey, which it does in a year, of course, and around the Earth is going the moon, and you can see that once a month the moon will come roughly between the sun and the Earth, so you might expect to get a total eclipse every month.
And sadly we don't.
But unfortunately not. The reason being, here's another point of view. We're now in the plane of the Earth's orbit, and you can see that the moon is in various different planes throughout the year, and there's only one point where it will actually cast a shadow on the Earth, which is the eclipse condition.
And you ought to be in that shadow.
We have to be in that shadow. In fact, here's a little bit more explanation. This is the classic line diagram. The sun casting its light on the moon casting a shadow on the Earth, which is quite big, as you can see, but most of that shadow is a partial shadow, the penumbra, and if you were standing in this large shadow area, you would see a partial eclipse of the sun. There is one little spot right in the middle, a little black spot you can see, which is the total eclipse position. We have a rather nice computer simulation here. The Starry Night program shows what you would see if you were standing on the moon and looking towards the Earth at this time. So if I press this button, we can actually see the shadow of the moon going across the Earth here, the penumbra, and right in the middle, very small, a little black dot, which is the total eclipse path. And we'd have to be standing right in the path of that little black dot to see the total eclipse. Very small.
That's where you've got to be. Well, now that, of course, is a computer simulation. So let's now have a look at the real thing.
Yes, this is quite spectacular, isn't it? Courtesy of NASA, a picture from space of an actual eclipse. In fact, last year's eclipse, which we viewed from the Caribbean. And there's the shadow going across the Earth. Quite amazing.
And yet, you know, Brian, we on Earth are very lucky to have total eclipses at all.
Absolutely. There's another little simulation here, which is what you would see if you were standing in the path of that little black dot. And here we see the sun, which you would be looking at with protected eyes, of course. And here comes the moon, and it just, by an amazing coincidence, seems to cover exactly the right amount of sun, which is incredible, isn't it?
Sheer chance. The sun's diameter is 400 times that of the moon, and the sun's also 400 times further away. But for that, no total eclipses. Really an amazing coincidence.
Incredible, and they say there's no coincidence in creation. Makes you wonder, doesn't it?
Well, anyway, we're going to have one or with it. So let's now start talking about how to view it. And one thing is paramount, and that is safety. The sun is dangerous.
We've shared a couple of expeditions, haven't we, Patrick, to places where people are very afraid of solar eclipses, and it's really not so stupid because people can do such damage to their eyes by not taking the proper precautions. We have to say here, you do not look at any partial eclipse of the sun, partial phases, without protection.
Or at any time. So let's begin, Shirley, with the naked eye, with no telescopic equipment used. And the thing that is not to do, don't stare at it. Only when the sun is completely hidden and you see the corona, only then is direct viewing safe. Other times it's not. So begin with the naked eye, and we do have these various filters that are safe.
Yes, this is a Mylar filter, which I've used before. They're perfectly safe as long as they're not scratched. You really have to be very careful. If they're scratched, you're in danger. Look for the...
Yes, you've got to have that certificate on it. And if that's not on in your filter, then throw the filter away.
Absolutely.
And I'm afraid there are various filters going around that are not stamped in that way, so don't trust them.
Yes, really don't take risks.
No.
Don't start looking through photographic film or blackened glass. Use one of these approved viewers.
Yes, smoke glass is no good, photographic film is no good, sunglasses are no good.
Absolutely not. This is the one I'll be using, something like this, and this is not subject to scratching. It's a very, and gives a very good view of the sun, as a matter of fact. This is another version of it. I guess this is the grown-up version. I'll probably be using something like this. Or else, the alternative is to project. You don't have to be looking at the sun to see the effect of the partial phases. You can make a little pinhole in a card like this, or else get this from your local optician, and project an image of the sun on a white card down here. I think that's a very good way to look at the partial phases.
Well, now turn to telescopes and binoculars. And unless the sun's totally eclipsed, there's one golden rule about looking direct, and that is don't. You can do it, a special Mylar filter or a welding glass filter to go over the far end of your telescope or binoculars, then you can do it. But I think the best way, in my view, is to use your telescope as a projector, pointed toward the sun without looking through it, and then shoot the sun's image onto a card or screen held behind the eyepiece, and then you have a good view. But otherwise, don't. And say, remember, the tiny part of the sun left uncovered is dangerous.
Absolutely.
And, of course, you've got to be in just the right place at just the right time. And so far as England is concerned, down in the West Country.
I think it's worth saying here, there's not a lot of point in seeing a partial eclipse, even if it's a 99%, because you're missing all the fun, basically. You know, so don't be in London. And you can see from this map exactly where you ought to be. I mean, even Bournemouth is not going to get a total eclipse. Even Exeter is not going to. It's much better to be on the centre line than it is to be near the edges, because you get a longer totality.
About 2 minutes.
Absolutely. I think Penzance and Falmouth, you're up to about 2 minutes. But if you happen to be, for instance, near Torquay in Teignmouth, you'll get about 10 seconds of totality only. So try to be as near the centre line as you can, and we hope it's clear.
Then, of course, it goes across Europe.
Yes, if you're lucky enough to be on holiday in Munich or Bucharest, the view should be pretty good from down there as well, I would guess.
I know some people actually bought to go to Paris. Well, look at Paris. It's outside the line. Therefore, Paris is a total non-starter.
Absolutely. Don't go to Paris.
No, go somewhere where you're right in the middle of the central track, I'll say, where the weather is good.
Absolutely.
Right. Now, our great day is approaching us. Let's take our viewers now through what to get to see, starting with first contact.
First contact looks a lot like this, doesn't it, Patrick? We're seeing about 9:57 a.m. The moon is just beginning to move across the sun's face, and over the next 1¼ or 1.5 hours, the moon, of course, just takes up more and more of the sun's light, and eventually you'll be down to a little crescent, a thin crescent of
You know, for the
sunlight.
first half hour or so, it's amazing how much you don't notice.
Yes, not much happens to begin with, but by around 10:30 a.m. things will start to feel very
yes.
different. It's starting to get dark, it's starting to get cool, and all sorts of weird things are happening, like with animals. You know,
Yes, animals notice it.
Yes, birds decide it's time to go to sleep, and you'll notice a very strange quality about the landscape. Shadows start to be very sharp, and
Well, other things to see too. What about if you're near a tree?
absolutely, underneath the tree you may see something like this, a whole collection of little images of that crescent sun. It's something very unusual. You can actually hold a pencil up as well and look at the shadow, and you'll notice the shadow is completely different depending on which way you'll turn your pencil. A good idea to look around, because when it gets near to the time of totality, you know, we're a couple of minutes before now, everything starts to happen, doesn't it?
And when totality comes, it comes with amazing suddenness. Bailey's beads first.
Yes, I guess the first thing you notice is probably the planet Venus will become visible. That very often happens, doesn't it?
At least half an hour before, very often.
Yes, I think so. And then probably if you're looking over your right shoulder, you'll see the shadow of the moon come rushing towards you over the landscape.
Lovely Douglas Arnold photograph there.
A wonderful picture of it there. And of course, a few seconds later, you will be in the shadow completely, and all the light will be in the distance. It's a very eerie sight indeed.
And then suddenly the skylight fades, the sun disappears, and then you have the corona in all its glory. The sun's
Absolutely,
atmosphere.
yes. There's a very beautiful time at the onset of totality, called Bailey's beads, where this thin crescent of sunlight will split up into tiny pieces, and Bailey's beads are your last vestige of sunlight, just peeping through the valleys of the moon, effectively. And then all of a sudden, it's gone, and we're into totality, and suddenly you're presented with this wonderful corona, the sun's atmosphere.
The sun's pearly atmosphere in all directions, and you may see prominences.
Yes, it's a good time to pick up your binoculars, I would say, because at this point we're safe, aren't we? At this point you can put down the viewers, and you can actually look at this totally eclipsed sun with your binoculars, if you like, maybe 7 by 50.
Yes.
Nothing much bigger than that, because it's very hard to hold it steady otherwise, isn't it?
I think this is the whole point. When you can actually see the corona, then it's safe to look through binoculars, telescopes, anything you like. And when you can't see the corona, it's not. And if you follow that dictum, you can't go wrong, I think.
Absolutely, yes. And there's an awful lot to see in this couple of minutes. I think it's well worth not fiddling with your camera.
Yes, take photographs by all means, but I say, I think word of wisdom here, don't spend all your time photographing, otherwise you'll miss the glory of it. And also, rehearsal is so important. Get everything ready, have your camera set up, cable release, and click at the right moment.
Yes.
But don't waste time doing all kinds of adjustments at the last moment. You won't have time.
Absolutely. And no flash pictures, please, because
Yes, that's the vital thing. Don't use flash.
it definitely ruins everybody else's view, and you'll get some very angry astronomers next to you.
It's been done, you know.
Yes. So we're looking at the corona with our binoculars. We can also see, if we move in closer to the eclipsed sun, these wonderful prominences. If we're lucky, we will see these wonderful red eruptions of hydrogen gas. There's some great pictures here taken by Paul Coleman, which show something which looks like a rather small flame, but in fact it's enormous. And if you had a picture of the Earth next to that prominence, which we see on the left there, the Earth would be just a tiny dot.
And of course we can't tell yet whether there are going to be any really good prominences or not. Depends entirely upon the state of the sun. The sun's a variable star. Every 11 years it's active. We're getting up to the peak activity now, and therefore we should have a fairly symmetrical corona and nice prominences, but we can't be sure. Every eclipse is different.
Yes, that's part of the fun, isn't it? Wonderful. I think one thing we'll definitely see, if the skies are clear, is the chromosphere, which is a beautiful pink glow, which is normally completely wiped out by the sun's brilliant photosphere. The eclipse time is the only time we see that. The chromosphere.
And then, of course, other things too. By now, the sky is darkish, and therefore you'll certainly see Venus and probably the other planets, and some stars also.
Yes, we hope. Again, this is a picture I took in Mexico, where you can see Venus and Mercury next to the eclipsed sun. Supposing you could see all the stars at that point, which we won't, you'd see that the eclipsed sun is actually against the background of the winter stars. We can see Orion there. Probably we'll just see Venus and Mercury and a couple of the brighter stars, yeah, I would say.
And of course, one never quite knows. Way back in 1882, an eclipse occurred, and near the sun was a bright comet. Never seen before, never seen again. And I just wonder, we could have a comet, very unlikely, I feel, but we just could.
You just never know, do you, what you might see.
And then when totality ends, it ends with surprising suddenness. And the first thing is the appearance of the diamond ring.
Yes, and it's quite stunning because your eyes are dark adapted by this time, of course, and it's a brilliant effect. It'll suddenly shoot out there, and this is the signal again for safety. You have to start looking away pretty soon at this point because you're going to get blinded by this light which is reappearing. It's a good time to look away and look around. Also a good time to look down at your feet because you may see these elusive shadow bands which are much talked about. I saw them for the first time in Curacao. I didn't really believe in them up to that point, I don't think. But it's a little bit like standing at the bottom of a swimming pool because you get these strange fringes which are moving around. We are, of course, standing at the bottom of a sea of air which is turbulent. And at this moment in time, the sun is virtually a point source. So this is why you get this very special effect. A nice little thing to look out for. But then, of course, it's all over.
Yes, indeed.
Sadly.
And, of course, one thing we must admit straight away, we are entirely at the mercy of the weather.
Yes.
If the sky is partial clouds, you may be lucky, and don't give up too early. But if it's totally overcast, then I fear there's nothing you can do, really. You'll note the drop in temperature, note the drop in brightness, and I'm afraid that will be all, and have to rely upon pictures taken elsewhere. So let's only hope that doesn't happen. Where will you be, Brian?
I'll be in Cornwall at my friend Roger's house, and we'll celebrate whether we see it or not, I think.
I shall be in Cornwall, just outside Falmouth, doing a commentary for the BBC, so let's only hope for clear skies. And if we fail,
Lovely.
well, there are other totalities. There's one in 2001, for example, in Africa, and they do occur every 18 months or so, but so far as we are concerned, well, as we said, the last was in 1927, the next will be in 2090. Therefore, so far as I'm concerned, I think also as far as you're concerned, this is our one and only chance of a total solar eclipse visible from England.
For the next 90 years,
Exactly.
yes.
Let's hope for clear skies. Brian,
Absolutely.
thank you very much.
Thank you so much, Patrick.
Well, it's newsletter time. If you want your newsletter, send your stamped list envelope to newsletter number 74, The Sky at Night, BBC TV, London W12 7TS. We have, of course, got our website, www.bbc.co.uk/skyatnight/. We have our usual information line, 0891 800 330, or CFAX page 620. Now, we're all getting tensed up for the eclipse, and when I come back next month, I'll be joined by Dr. Peter Cattermole and Ian Nicholson, and we give our very last pre-eclipse rehearsal techniques. And therefore, let's hope that we are going to have clear skies. And for our last pre-eclipse program, we'll see you next month. And after that, the great day will be upon us, our one and only English total solar eclipse. Good night.